with the interests of doctors, because we have a perspective of folks, who are doctors on our board. We also have an outside board that advises from a medical capacity. So, for example, we have an anesthesiologist, which is very important in terms of understanding toxicology and medicine in that particular way. So again, we're big enough for everybody's needs, but we're small enough to be personalized and provide good service. All of the testing is done within the four walls that are here. We have a bilingual customer service staff, which is very important, not just for Florida, but for places like Texas, New Mexico, Arizona, California, Chicago. The second largest Cuban community in the U.S. is in Chicago, so that's important. So why CBS? We all know that every lab is the same, right? I mean, if we look at the two big competitors, LabCorp and Quest, they all have an experienced clinical team. We all have an experienced management team. We all strive for clinical accuracy. We can all interface with electronic health records. We can all deliver reports through an online portal. So everybody's going to say all labs are the same, right? But we know it's not.
No.
In fact, the reason CBS Labs exists is because there's opportunities there that people aren't satisfied with LabCorp and Quest. So what makes some of the differences? Personal service. We have no regulatory issues, no inspection deficiencies. Remember I mentioned there are laboratories that pay hundreds of millions of dollars a year
in fines.
Those are the ones on the right side of that graph. We're local. And local doesn't just necessarily mean down the street. I mean, because of our personal touch and our technology, we can be local for somebody in Alaska. We're not a national chain. Why is that important? What's the national chain focused on? They're focused on their quarterly financial reports, reporting to Wall Street, all those others. We're focused on getting answers, clinical answers to our clients. We're a lab where a person answers their phone call. Wow, what a concept, right? Somebody actually says, hello, CBS Labs.
Is this a recording?
And again, we have bilingual support staff. Again, very important, very important.
May I ask what the cons are?
The cons of us, why someone wouldn't want to use CBS Labs? Mm-hmm. Okay, probably the biggest objection you'll get is, oh, that's a little lab in Miami. We all know there's corruption and bad ethics in Hialeah. But you know what? There's actually a good lab in Hialeah. Okay. That's one of the cons that we have to, misperceptions that we have to deal with all the time. South Florida is the Medicare fraud capital of the world.
Really?
So us being here, we get that smell, if you will, automatically, just because we're here. But why are we in this zip code? There's two reasons we're in this zip code. One, people live here and work here, but two, we're here because the real estate is really inexpensive, which allows us to afford this. If we were to move this to downtown Miami, we'd be at a quarter of the size. And the cost would be eating us alive. So there are ethical labs here in Hialeah. What other cons might there be? What other reasons might there not be to choose CBS Labs? Someone may have a relationship with another laboratory that's personal. If I'm a doctor and my wife works in another lab, I'm probably going to use that lab, right? As far as other things, I mean, I can't think of anything.
The good old boy theory is your biggest one.
Mm-hmm. Yep.
I've been doing business with you for 40 years, why should I change?
Absolutely.
I went through that 10 years ago. We had a site called Fed Center.
Mm-hmm.
Very good. But these guys, they didn't even have computers. Mm-hmm. They still had telephones you dial. Mm-hmm. And they, instead of, the government doesn't order one pen. Mm-hmm. The government orders 1 million. Mm-hmm. Now, if you could take that 1 million, okay, and get it into the government of each state and trickle down factor it to the cities, you can turn that into 600 million, mm-hmm. okay, you can actually save 3% on cost on raw materials. Mm-hmm. They didn't buy it.
Amazing.
Yeah, there's all kinds of stories.
Right. So again, the famous HTs, right? If you were to ask people this, and we encourage you to, how important are the following to you in a lab? I'll tell you right now, people are going to want 10s on everything. This is the lab that they're going to want. Somebody who's on a scale of 1 to 10, a 10 of everything. That's an important shape to remember, because this is some examples of labs that are out there. Now, really, when it comes to the high talent, unless you're talking like an oncology research center where everybody there is an MD, PhD, that's the high talent. So out in the real world, you're not going to run 10s. But you can be high trust, you can be high touch, you can be high tech. And so if you were to ask a physician or client or prospect, which of these labs would they want to choose? It's kind of a no-brainer, right? So the actual names that are attached to them are this, based on a survey.
Can you go back to that slide for a sec, Robert?
Sure.
Thanks.
So really, those are the only two LabCorp and Quest is the competitions, leave it at that.
If
sure
you
there's
can
others,
compete
but-
against LabCorp and Quest, you can compete against any other lab that might be out there.
But those are your targets.
Those are-
That's
and
where you
also-
draw the bullseye.
Those are the ones who have, if you walk into an office, there probably one of those two will be there, and you can easily replace them, and along with that, anybody else.
And Bob, can I, speaking to that,
Mhm.
because LabQuest and LabCorp facilities are all over the place, so for those patients going.
You mean the draw stations?
Exactly, yeah. so-
Phlebotomist.
Yeah,
Right,
yeah,
so
phlebotomy station.
you can,
Mhm.
so I'm just thinking a little bit about that and trying to overcome that objection
Mhm.
if, physicians are saying, well,
Couple of ways to overcome that. We have draw stations,
okay.
and we're in a build-out phase throughout the state to increase those. Many offices and clinics draw their own blood, okay? And we can do home phlebotomy. So instead of the patient going and standing in line at a Quest station, we can send a phlebotomist to their house who can draw the blood right there in the comfort and convenience of their home.
What are the qualifications for that? I mean, there must be a cost factor where you
For-
can't be
for-
it every single time.
For Medicare, Medicare requires the patient to be homebound, but other than that, we can bill it to the insurance. And worst case, the patient would pay the $10 out of pocket, and a lot of people would prefer to pay the $10 than try to find
It's
a
only
parking
$10
spot.
really?
Thereabouts. yeah.
About that, it's not
Yeah,
like,
yeah.
okay.
So then try to find a parking spot, wait in line, go from one place,
Yeah.
doctor's office to the draw station. You look like you have a question.
I do. So do you only do the South Florida region for that?
No, because we
Okay.
have phlebotomists throughout the state.
Okay, so their whole
And our-
territory is the whole entire state of Florida?
And our couriers are all phlebotomists also.
Okay,
So that's why the cost can be cost effective, because they're already out and about. It's not
Right,
like we're
right.
sending someone from here to go get
A to B.
specimens.
so we can market Orlando and have someone get sent to their house in Orlando?
Yeah,
Okay,
or at night, weekends, Saturdays. Here, this is one of our draw stations too. You saw the phlebotomy chair right by there. We're open on Saturdays. A lot of people have to get their blood drawn on Saturdays.
we work 9 to 5.
Oh, so again,
What
client,
about other
I'm sorry?
states? What about other states?
We don't have any in other states, but if there's a nucleus of volume, we can certainly put one.
Okay.
So our goal here is client satisfaction.
Satisfaction.
Yep, absolutely, on cross the board. Workflow, you had a chance to see workflow, while we walked through the laboratory tour. So we have the sample pickup, the sample intake, which you know about, the sample testing, which we discussed, and also the reporting. So that's the workflow, basically in the laboratory. So as the samples get picked up here's a picture of some of the cars. And the
Nice
fees.
and clean, that's a big point.
You know what? That's why some of them are out there right now. The guys are out there washing cars.
Big selling point.
So again, on the sample intake, we do the information verification, very important. Remember, quality is part of our driving factor. So making sure that we do what we call true positive ID, TPID, all the way through the process, because we want to make sure this specimen that we're reporting is this patient's, it all matches through. That's very important. Real life case from a company called CBL Path, not related to us, CBL Path. Somewhere in their processing, they mixed up 2 breast cancer biopsies. They reported out to a woman that she had breast cancer. She had a bilateral radical mastectomy. After their surgery, the pathologists at the hospital were looking at the breasts and found no cancer. 6 months later, the laboratory was able to identify which patient that had been swapped. That patient had received a report of benign, but now, of course, 6 more months had progressed.
And stage 4.
So she had bilateral mastectomy also. All of that could have been avoided by proper processes in the laboratory. That's what we strive for all the time. That's why that sample verification is so important. So testing, you recognize the AbSci-X toxicology machine there. And here again is the turnaround times, whether it be 24 to 48 hours, 5 days, depending on for example, the DNA and the like. And again, we operate 3 shifts, 6 days a week and 2 on Sundays. The reports, every report is available in our online web portal. So when your client is set up, they get a username and password, they can log in, they get the results. As soon as we close the case, they're on their web portal. And it can always be tied into the EHR system as we move forward with the client. So that's why CBS Labs. You can talk about the differences and the things that make us unique. You can talk about the HT4. You can talk about the true positive identification. LabCorp and Quest lose specimens all the time. Yes, they do.
That's terrible. I mean, and as a patient, you don't even know where your analysis is going. Like you can't even control that.
Absolutely.
It's terrible.
Say that again?
Like I'm as a patient, for example, I go to a doctor and I don't even know like where those analyses go. So if he tells me like, oh, you have this and that, or you don't have it, I don't even know for sure if it's true or not, because the laboratory could make a mistake or something. That's crazy.
It's interesting.
Is there anything, because you have such a wealth of what you do, that stands out, like when you, as your competitors, like, do you think you're ahead of the game in pharmacogenetics, or, is there anything?
As far as like a clinical area,
Right.
where we stand out?
Right.
I would say that in the molecular, we stand out extremely high. Toxicology has been very, very well received.
Okay.
People like our toxicology. Another area where we stand out is in cytology. Remember, that's the fluids of the body, so the pap smears, the breast aspirates, thyroid aspirates, sputa, things like that. So the types of doctors that do that are, pap smears are family practice doctors and GYNs. Sputa is family practice doctors again, pediatricians, pulmonologists do that. Anybody dealing with flus and coughs and colds in the lungs. With the aspirates, like the thyroid aspirates, would be the endocrinology doctors. Yep, absolutely.
Oh, I got it.
They stick the needle in there and suck the juice out, and we look at the juice. So those are the kind of the people that we would use. So let's move on to toxicology, and we'll try to get everybody out of here at 2 like we promised, because it's a beautiful day, and once you reach a certain level of brain, it just doesn't sink in.
And one thing, sorry to print this question, and thank you, is what you seem to do that I haven't seen when I look at other your competitors is the wealth of knowledge you put behind.
Absolutely.
Which I think is a huge, selling point.
She's on the same subject. In my opinion, I think that each of us, well, at least me anyways, should go look at Quest or go look at the other ones and see what, see what kind of engineering their platform is, so you have a better understanding for the attack. They do this, we do that.
Yep.
They do that, we do this. They can't do this, we do this,
Yeah,
this,
yeah,
and
I
that.
encourage it.
So,
Yep.
yeah, so you know exactly, that's how I approach all my clients. 'Cause I wanna know all the answers before the questions are asked. Then I got control of the conversation, I
Right.
got control, and then I can close and make the sale. And then you always wanna hype the guy up for what a great business he's got. They're all egotists.
Yep.
Yeah.
Oh, man, thank you. Oh, yeah, he knows my business.
So toxicology touches on virtually every area of medicine, whether through research or pharmacy, response to drug treatment, monitoring for therapeutic dose, things like that. And we don't need to get in too detail on that
Yeah.
slide. So medication monitoring is a very, very interesting and underserved area in toxicology. Usually when people think of toxicology, they think of drug rehab centers.
Right.
Medication monitoring is very important because what we want is, if this is the therapeutic level, we want the patient's drug to be right in that therapeutic level. And with toxicology, we can identify if the patient's too high or too low and make adjustments.
Well,
based on-
what about the collision force in toxicology? When you get medications that they give you, that they don't interact, they
Correct.
smash, and then you got big problems.
Absolutely.
And a lot of times the doctor will give you something else to correct that, and it only increases the
Yep.
falsity of that.
Yep, so medication monitoring is very important.
Okay.
So with toxicology, we have two parts: the screening, which is the inexpensive, not so accurate test. The reason that's used is because you're doing a lot of people, so it saves the healthcare system money. And then things that come up in the screening test may be positives or negatives. If you expect it to be positive, it's a negative.
What about false positives?
That's one of the other issues,
Okay.
false positives, false negatives with screening test. Then that goes to confirmation. So we use the inexpensive method to screen, and then we use the expensive one to screen to confirm that subset that needs
So
it.
it's a double set.
Right. And so the confirmations are all done here on the LC-MS instruments, the
Right.
liquid chromatography mass spectrometry. And you saw those yourselves when you
Yeah.
were over there on the tour. And by the way, Wolf is going to take this and put it into the new format, and you can use this presentation also, you know, talking to a doctor. Addiction treatment and recovery. That's the area people think of usually for toxicology. When it comes to these areas, there's a whole bunch of little tiny toxicology labs all over the country, and they focus very heavily on addiction treatment and recovery centers. They skip the medication monitoring guys, they skip the therapeutic dose guys, because all they're interested in is that area. So you can work both and work back and forth between them, because oftentimes the medical director of a drug treatment center is a pain management doctor, for example, in town, and is seeing private patients separately. So you can work back and forth and pick up lots of revenue that way. So again, the comprehensive urine profile, remember in the previous, we talked a little bit about the basic, but the comprehensive has all of these in it. And the doctor can always add more if he wants. And again, always the specimen validity test.
What would anybody have ethanol in their system?
Ethanol? From drinking?
Alcohol.
Heavily?
Ethanol is from drinking?
Alcohol.
That's the
Oh, yeah.
alcohol.
Alcohol is ethanol.
Yeah, the one that you
Because I'm
can
thinking
consume.
ethanol as in bio.
Oh, yeah.
You know what I'm talking
Well,
about? For gas,
that's
for fuel.
That's why
That's what I
the
got.
reason they mix it with gasoline is so the bungs don't drink from the
10%.
gas pump.
They give you 10% right now of ethanol.
Yep.
Excuse me, I learned something today, made a fool of myself.
Not at all.
Okay,
And again, you know, we do have, and pardon this slide, for some reason on the TVs it always comes out fuzzy, but on the tablets and print it comes out clear, and the computer screens it comes out clear. But this shows the 96 different categories of drugs that we're testing. And doctors can always customize this and add some of the strange things if they want. This is also duplicated on the, requisition form that's in your packet. So, you have that.
How does the insurance billing change? Let's say I mean,
Mhm.
is this an average would be tested for, or more like just 5,
No,
6,
no,
or
this
7?
is, usually people are in like the 10 to 12 range.
Right. 6
But
or
we can
12
do-
panel or
Yeah,
something,
we can
right?
we can do very, very comprehensive testing.
Now, I know you said earlier that you're running all 96 anyways.
Right.
So if the doctor requests, let's say 20 or more, would that increase what you bill insurance then?
It has an effect on the insurance billing, but what the insurance doesn't pay anymore, insurance used to pay by
By.
drug category, now they pay groups.
Groups.
So like 1 to 10, 11 to 20, and so on.
Oh, I
So the
see.
difference between 12 and 14, there's no difference in,
Okay.
in money
Right.
coming in.
Will we have a list of how much it costs per,
Every insurance pays differently.
Right. Yeah. Every insurance pays differently.
For each test, so there are so many variations, but you will see later on on your reporting, once you log into your client and you kind of see certain values, right?
so would we want to target those practices that has those insurance companies? So let's say if Aetna gives more money on toxicology labs here, so we want to target physicians that, or practices that use Aetna insurance then?
That's one approach, yeah.
That's, I would say, a very fine, detailed
Yeah.
approach, if you can figure out that detail, because I don't think that's, if you would get that from a doctor,
Well, you can.
unless you know.
You can, so let's say if I'm a client going into a doctor's office, I wouldn't go to a doctor's office that doesn't take a certain insurance. So you could call them and see if they accept that insurance or not. And then if they are a list of insurances that we have, then I would go to that practice and target those insurances through those practices.
Yeah, that's it.
Now, how does this gel with Medicare, Medicaid?
Covered by Medicare and Medicaid
Okay.
also, yep.
Okay.
The reimbursement rates are different, of
Different,
course,
of
which
course.
you'll see, I think.
But
Is this
that's a high volume,
This is just the toxicology, okay.
and Medicare and Medicaid is a high volume.
Well, less, it depends. In the therapeutic monitoring side and the like, pain management side, yes. In rehabilitation and drug treatment, you see that less so.
Less. Oh, yeah, George, okay, I understand.
So, that's kind of like the overview of toxicology. And as time passes, we'll have more training, both distance learning or if people want to come in here,
Yeah.
because we want to utilize our technology. A lot of times it's easier to just log in for a half hour, as a refresher trainer, handle questions and things like that.
Well, this is an ongoing thing, I can see that right now.
And we're putting a lot of information in front of you first, so you
Yeah.
can,
Well, then you'll narrow it
begin to
down.
put the basics, yes. So on pharmacogenetics, if you look on that wall right there behind, you see molecular in big letters across the top. And then you see on the left, you see PGX, which is pharmacogenetics. You see inherited disease, you see infectious diseases, and you see oncology. Those are the four main categories under molecular. So pharmacogenetics is one of the categories in our molecular department. The last one is research, so you don't have to worry about that. But that's kind of like the overview there. So, some people like to say DNA, but that's kind of slangy and not specific. So we like to say molecular and pharmacogenetics.
Spell that.
It is spelled just like
There
that.
it is. Oh, thank you very much. So I wasn't
There
going
it
to
is.
make an attempt at that one. I'm telling you.
So usually, Dr. Sotolongo gives this talk, but she's running specimens. Actually, she came in today and she's running specimens, so she's not free to break away, and we want her to be running cases. But she earned her PhD from Rochester, worked in a very, very famous molecular lab up there, and has also worked out in Hawaii and some other places, as well as here. So what is pharmacogenetics? It's the study of how the DNA and RNA affect your body, your body's DNA and RNA affect the way drugs are metabolized by you.
Repeat that now.
Yep, certainly.
Study of how
DNA and RNA.
DNA.
You're getting access to all the slides, by the way, so it's You're getting all that.
I'll get on the computer.
Yes.
Oh, okay.
But still, it's good to take.
You can still take notes, but I'm just
Yeah.
saying.
Yeah.
Because I will be all over this thing, it's gonna take me a day or two to get.
So it's how your DNA and RNA relate to drug response, because yours may be very different than mine at the genetic level. So again, just as a kind of a reminder, the important thing here is the first line. You have your DNA, you make an RNA, which the RNA is then used to make a protein. So if your DNA is slightly different, you make a slightly different RNA, which means you make a slightly different protein, or you don't make a protein.
And those proteins would be your amino acids and all that?
Any kind of proteins in the body, because all the proteins are used. Proteins include things like enzymes and all kinds of molecules that affect the body. So in 2010, the FDA recommended a genetic test called CYP2C19 be done prior to giving out Plavix. This is one of the tests we run. And we'll go into some detail why in a bit, but that's the FDA recommending that, not us. You know, you'd asked a question earlier about are doctors seeing more and more. Doctors are seeing more and more the clinical utility of pharmacogenetics. They're seeing it more and more. So what this slide shows is you have people who are kind of like in the middle, what we would call the normal. You have people that are poor metabolizers of drugs, and you have people who are ultra metabolizers of drugs. People who are poor metabolizers don't break down the drug fast. People who are ultra metabolizers break it down really fast. So what that means is to get the therapeutic dose that we were talking about, the therapeutic response, poor metabolizers get less, ultra metabolizers get more of the drugs. That's what that graph is showing there.
Is this all linked to thyroid function?
I'm sorry?
Is this all linked to thyroid function?
Liver.
Liver.
This is liver. So the applications in pharmacogenetics, we see drug development, individual drug therapy guidance for patients, predicting adverse reactions, and identification of increased sensitivity to drug interactions. So we can tell all this just from the molecular pharmacogenetics test. So here's your answer on the question. It's about the metabolism of the liver. We found the cytochrome P450 family back in like 2010, and that's responsible for over 85% of all medications taken, the metabolism of them. What that means is if you have a change genetically in your liver function, you metabolize those drugs differently. There's 57 different active genes in 17 families, and the most important ones from drug metabolism point of view are the CYP1, 2, and 3. And you can see how they name these. For example, where you see like in the line number 3, CYP2. If you go to line 4, you see it's CYP2B6, CYP2C9. Those are the names of the specific genes. So these 5, the 2B6, 2C9, 2C19, 2D6, and 3A4, are responsible for metabolizing the most clinically important drugs. So here's some examples. 2B6, methadone. And actually 3 to 4% of Caucasians are poor metabolizers. We're only putting the poor metabolizers up here just as an example. There's also ultra metabolizers. Why is this important? Let's say I'm in a drug rehab program and I'm on methadone, and I'm a poor metabolizer. Here I am, I'm addicted to a painkiller. You're giving me an interim painkiller, but I'm a poor metabolizer, which means the dose you're giving me is too high for me anyway, because I'm a poor metabolizer. It's going to build up in my system. And I'm not going to do well in my rehab because you're overdosing me. Pharmacogenetics can tell the folks that, so we can get the right dose.
And weight and all that also has to play a
Yep,
factor.
those play a factor too. 2C9, if we look at some of the drugs here, warfarin,
Thinner.
blood thinner.
Blood thinner.
So if a person can be overdosed or underdosed based on their genetics, and you don't know who out of the population that is.
You know where
we can tell
warfarin
them.
came from?
No, no.
It's very simple. It's a genius. It's a farmer.
Oh, really?
Gives it to rats
Mm-hmm.
to clean this place out, and the rats eat it and warfarin thins. So they have to come out to get air because they're bleeding out of their noses and out of their ears. He had something like 700 rats out in front of his barn on the side.
Wow.
And that's because that other stuff. What do you call it? The other blood thinner starts with a C. Cause
Yeah, the brand name Plavix, yeah. Clopidogrel or something.
clopidogrel, right?
Yeah.
This warfarin, they watch that carefully because that'll really thin your blood out. And if
Yep.
you're a free bleeder,
Absolutely.
it ain't gonna happen.
Mm-hmm. So 2C19, these are some of the drugs that are modified by that. And you can see that it also varies racially. 20% of Asians are poor
I
metabolizers.
mean, it's every fifth person who will have an issue.
Right. And if you look on there, one of the drugs that is affected by this gene, the metabolism, is progesterone. What is progesterone in? Birth control pills.
Birth control, see.
So women can be unintentionally overdosing on progesterone.
Didn't they just have
Not
a big
realizing
issue about that here in the last 6 months?
Might have.
They did, though. They were suing.
Another one, 2D6. The second drug from the bottom, tamoxifen, is used in breast cancer treatment. So you already have a woman who has breast cancer who could be a poor metabolizer of tamoxifen, and the oncologist is giving her tamoxifen. So what happens if she's a poor metabolizer? Today she has this little drug, the next day it goes up and up. So she's overdosing on a drug that we wanted to give to her to help her, and instead we're doing harm. So pharmacogenetics has a lot of applications across a lot of different fields.
Almost mandatory in a sense.
And here we go, your favorite, warfarin.
Warfarin.
Warfarin is #1 in total mentions of deaths for drug-caused adverse events.
effects.
#1. It's among the top associated with bleeding, because what happens? Someone takes, it's not that they're taking too much, they're taking what their doctor said, they're a poor metabolizer. They start bleeding out, they go to the ER.
I mean,
And it costs millions and millions of dollars, billions of dollars to our healthcare system every year. That's just a complicated chart, but basically if this is normal dose, we'll say 3. If you have this gene structure, remember how I mentioned we can tell the difference between just an A and a G?
G.
Okay, if you have a difference from the A to the G, and on here, on this gene, you have this gene structure, you need twice the dose of
To
this
have the same
drug
effect.
to get the same effect. If you have 2 A's and a 3, you need,
1.5.
no, 50%.
50%, okay.
less drug to get the same effect. So if you're one of these AA 3 people, and I start you out on this, you're already getting overdosed. And we can answer that question for folks. So you saw the Magna Pure, you saw it personally, you saw the automated pipetter and the model. She wasn't there today, I'm sorry. You saw the microchip. These pictures are here so that if you show it to a doctor, you can say, here's the instrumentation we use. This is the process, which you already know basically. We extract the DNA. We put a tag on it, we multiply it, and we count it, which is that picture. See, there's the tag being counted. We can run actually 96 samples at a time. Initially we were running them in duplicate. When Barbara prepared this, we were running in duplicates for quality control reasons, but she's satisfied with the assay and how everything works, so we can run everything in one. So, let's see. So who uses it? Primary care practices, pain management practices, internal medicine, cardiology, rheumatology, psychiatry. A lot of people very interested in pharmacogenetics.
Yeah, and then the whole mental health industry, which is huge, in all the areas,
Yep. Psychiatrists really like pharmacogenetics.
And the great thing about the mental health industry is that when you have a patient, they test them a lot, and they test them for month and month and month on time. So it's not just like the one-time blood test and get a little test done and you never see the patient again. These are patients that the doctor sees and tests probably possibly 3-4 times a week, and then weeks and weeks on end.
And part of the reason for that is, think of how many ADD drugs and ADHD drugs are in place, how many antidepressants are prescribed. That's a huge market in pharmacogenetics for us, because they want to make sure the patient has the right dosing.
We can screw that up real easy.
Yes, and you know,
Very easy.
and the problem is, the patient doesn't always know.
No, it doesn't know. And
The
so
patient
it's too
doesn't
late.
know, so you know, if you have a person who's depressed and you treat them with an antidepressant, how do they know that they're supposed to be here when they're really
Right
here?
I mean, it's
They don't
it's
know.
crazy. Like at this day and age, the doctor is like doing a guessing game on let's give you 5
Well,
milligrams.
he's rolling the dice is what he's doing.
How do you determine if, I mean, of course you go to you go to therapy and counseling if someone's depressed or whatnot, but how do they determine that someone needs medication because they're depressed and it's just not the patient wanting the drug?
That's the psychiatrist doing an evaluation
And usually
and finding a
it's-
clinical evaluation.
They give you a little, and then how you respond. They don't just slam you with it, because that can screw you up real fast. But they build it until you get to the point where I'm not depressed anymore, or you're at the point where you don't have anxiety. Anxiety and depression, in my opinion, runs parallel. Because you're very, very
We done with that?
manic.
Yep.
This, and this. You know, sometimes a depression pill is not going to help. An anxiety pill will, because they're running so close.
And then also in Delray, they have a lot of centers, AA centers and things
Well,
of
that's a
that
huge
nature.
business now.
Do you guys market to them as well? Do they
You
do
can
blood
absolutely
tests?
market to them,
Okay.
yep.
We work with a lot.
Toxicology, blood testing, pharmacogenetics testing, yep, absolutely.
Okay.
All right, so we're the last one, right?
Yep, last one. And then we'll have time for a little bit of conversations, because we want to make sure everybody gets out of here at a reasonable time. So if we look back on the wall over there, when we have our molecular listing, we have pharmacogenetics, we have inherited diseases, and then we have infectious diseases. These women's health panels fall under the infectious diseases. So in this case, instead of looking at the woman's DNA, what we're doing is looking at the DNA of whatever it is causing the infection. And again, Barbara usually gives this talk, but she's...
We can rest you here.
Yep. So, in the women's health panel, there are several bacterial, and she uses the word bacterial here in the generic sense, infections of women's reproductive organs that can cause pain, irritation, abnormal discharge, even leading to severe conditions like pelvic inflammatory disease. They can cause an increase in the risk of HIV infection as well. So the idea is to, and this, by the way, just in the over-the-counter creams is like a $5 billion market. So what will happen is patients will suffer from a vaginosis issue, start self-treating by going to the Publix or Winn-Dixie and getting some over-the-counter cream, finding that doesn't work, taking time off from work, getting into the doctor's office, trying to get some kind of treatment that will solve things. If you talk to any family practice doctor or GYN and say, do you have women who come in regularly for bacterial vaginosis issues or vaginitis issues, they will be able to name off 5 or 6 immediately. Because some women just have recurrence and we can't get to the root cause of the problem. We can get there through infectious disease testing at the molecular level in our laboratory.
Explain one thing to me, I'm ignorant on this. And it says there, and even increase the risk of HIV.
Correct.
I don't understand that statement.
That's because the infection causes changes.
From a cellular standpoint?
Well, no, here we go. In number 2,
Okay.
line 2 up there, the infection causes changes in the pH
of the vagina,
vagina.
3/8 to 4/4.
What happens is that becomes a more favorable climate
Climate.
for those viruses to survive.
Okay, so in other words, it's acceptable. You
So
can sponge it in.
Correct. It becomes more hospitable for the virus. It's usually
Hospitable.
less hospitable for the
I
virus.
understand now.
Okay. So in this case, the example she's giving at the bottom is Gardnerella vaginalis. And in this case, she's discussing a frothy, foul-smelling, itchy, burny urination thing that can lead to pelvic inflammatory disease and a cause for infertility. So PID is basically the infection spreading, so we want to catch these early. If a woman's in her 20s and she has chronic or consistent bacterial vaginosis or something, she can literally become sterile. And if she hasn't had kids, she won't be having kids. So this can be very, very life-changing.
Candida, boy, that's a big one, that yeast thing.
So there's 4 different panels, and we'll talk about these briefly. They're on the requisition form also, so the clients will be able to choose the one that's appropriate. So the resolve panel is kind of like the one to use when they don't know what's going on. It'll test for 5 different organisms, Trichomonas, which you see in the picture there. That's actually not a bacteria, that's a flagellate. It has a little tail at the end.
Flagellate, right.
Yeah.
What's a flagella, like a little animal?
A flagella is the tail.
Tail.
So you can see the tail pointing off at the end. It looks like a little hair sticking out the back. You have 2 species of Candida there that it will check for. It'll check for Gardnerella, and it'll check for 2 species of Mobiluncus, and that's all done on molecular, on the same PCR machines that we did pharmacogenetics. The molecular is the process, and the use is one of those categories up there. In this case, it's infectious disease.
But that's all yeast associated.
Well, there's yeast. There's a bacteria, which is the Mobiluncus, and there's a Trichomonas, which is a protozoan.
Protozoa.
Yep. So the next panel is the Candida panel, and we have a beautiful picture of Candida up there. So here you'll see we're looking at 6 different species of Candida. Why is it important sometimes to look at which species? If a woman has the same infection, let's say it's Candida krusei, over and over and over again, that means something is reinfecting her with Candida krusei. We can start helping her identify what in her or where it may be that. If this week it's Candida glabrata, and next month it's krusei, and so on, then there's different things coming to cause that infection. And so the overall goal is to get her healthy, but also prevent her from becoming healthy again. So having an idea of what the different bacteria or organisms, microorganisms is probably a better word, what the microorganisms are can help the doctor help the patient better overall. Does that make sense?
Yes.
Okay. The BV panel, or bacterial vaginosis panel, looks at a different mix. So they have the Bacteroides fragilis, which is the one on the right. That's a bacteria. You have the Gardnerella, 2 Mobiluncus species, the Etobobium, and the Prevotella. Again, all by PCR, same thing, it's all molecular, which is nice because, what we're doing, we're looking and we're finding this particular DNA in that sample.
So just for clarification, this is all being detected via DNA, not via microscope.
Correct. It's by DNA, not by microscope.
So it's just a certain gene that they're sequencing.
Yep.
If they have it, then they have that bacteria.
Yep. That bacteria's gene is there, that bacteria is there. Or that Trichomonas gene is there, the Trichomonas is there.
And then do you guys just then put the sequencing in the computer to just analyze, or do you guys actually go in and sequence each DNA and read through it?
What the PCR machines and the microchip reader do is they will, remember there's the DNA sequence we're looking for, they have a primer,
Yes.
right? So the primer is specific, there's 4 primers in there,
Yes.
okay, in the mix.
And then
Okay,
if they come up.
so if this is, say, the urea plasma urealytica primer,
Mhm.
they go, nope,
If they bind, then.
right? Oh, yep, it's this one. It binds. So you wash off everything else. It goes into the PCR machine. It makes that tail,
Yeah.
right? And then it counts it.
Yes.
If it's there, it's there. If it's not there, it's not there. So we don't have to do the higher end gene sequencing because we already have the primer that binds to that particular sequence.
Oh, that makes it a lot easier.
Yes. So, again, here's the protocol, which I just showed you in my hands, right? We extract the DNA, we put the primer on, we make it blah, 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 so we can count it, and then we do the signal detection and analysis. Same instruments that you're familiar with, same model, same microchip, except for it doesn't glow in the dark like that. Same process. Why is that important? That's important because of quality. You know, we're using a process. Oh, look, next gen sequencers. How wonderful. $500,000 each. So we can also individually customize panels. We work very closely with the manufacturer and development. We do a lot of very interesting things with them. So if we need to create custom panels, we can do that very easily.
That's a selling point.
Dr. Sotolongo loves to go over this because sample collection is very important all the way through the lab. You know that already. So since we're looking at DNA, what we want to do is collect the DNA and make sure we don't cook it on the way to the lab. Put it in a refrigerator, keep it at room temperature or something. Don't, none of this, put it by the space heater, leave it in the pocket all day while walking around before saying, oh yeah, this needs to go to the lab. No old samples. No samples have been sitting in somebody's trunk for a week. And these are all real things that have happened. Use the correct specimen collector for the correct site. So for the pharmacogenetics, we use a swab. They just take 20 swabs on each side of the cheek. They've already put the patient's name and date of birth on here. Swab goes into the fixative, snap off the end of the handle, seal the tube, and it comes to us. Okay? For the vaginosis, or the women's health panel, you use a swab. They would collect this just like a pap smear. Patient's name and date of birth goes on the container. Specimen goes into here, the end snips off and goes in the garbage, you seal the container and comes to us. So how do you know which one is which? Right? How do you know which one is which? Because she says, use the correct swab. We have instructions on the back. You'd be surprised how many times people in doctor's offices forget to look at the instructions on the back. So if it doesn't match anatomically, then it's not the right swab.
Do you provide these free of charge, or is
Yes,
there cost,
yes.
or how does it work with urine collection and all that stuff, anyways?
Excellent. So specimen collection devices, we are allowed to give at no charge to the clients. Because those swabs aren't just swabs. Those swabs have been validated by our PhDs on the instruments, and we know that if we collect a specimen with that swab, we know and expect to get a valid result. If you send me a swab from a collection where we've never validated it, there could be something interfering or some other factor that may give us invalid results. So that's why we put our collection devices there, free of charge with them. When it comes to urine toxicology, for example, we can provide a urine collection cup, which is just a urine cup that the patient can collect, it seals, and can come to us and we can do the screening and confirmation on there. If the doctor is doing his own testing, his own screening, we cannot provide him screening cups because that's a test that he can bill for. So what they do is they purchase that on their own, and we have a buying group independent of us. We'll make sure that you get the phone number of the representative, and they get a very, very good deal on cups as part of the buying
Do
group.
you know the deal right now?
$3.95 per cup.
Is there any way to get that down a little bit?
That's really actually very low.
Oh, yeah?
Yeah, yeah,
I
yeah.
know, there was somebody pushing me yesterday to go below 350.
There are, yeah.
I know, it's like
People
nickel and
always-
diamond and stuff.
If you said 350, they'd be at 325.
Right.
You know. You have a question?
I do.
I know your questioning face now.
I'm just like, for the swabs, I know that I heard the mouth swabs, they're not 100% accurate on getting all the information, they're not 100% accurate in detecting everything.
On the pharmacogenetic side.
Yes.
We haven't had that in effect.
Okay.
Maybe she's touching on something that the swaps was done, that just changed like a year, 2 years ago or something?
The
The way-
HIV testing.
Oh, for HIV testing.
I heard that was 100%
Okay.
accurate.
When we're doing HIV testing, we do it off of blood,
Okay.
which is much more accurate. So that would be the sample that we would run.
Okay.
But for the pharmacogenetics, it's the swab in the mouth, because all we're taking is the DNA of the person.
And it's kind of like, once you detect it, it's either yes or no. I mean, unless they're putting it in water and sending it in, then there's no DNA there, right?
Yeah, when you're looking for HIV in that case, and not HIV molecular infectious disease like we have up there, that's HIV in that back room, remember that one? That's off of blood, and that's very accurate.
Yeah.
And I can see where you might not get it here because there may not be virus in the cheek. So that,
I'm sorry.
go ahead.
It's just like this little sector alone, it seems that it seems very new to me, and maybe just haven't been in the clinical in a while. So it would seem like this would be phenomenal just to gynecologists alone.
Absolutely.
Education. Because if you can explain, I mean, the enormity of vaginitis and that, and all they're really looking for is usually one strain, it's usually albicans, and it's
Yeah.
like, nope, not that, and carry on. So
And
this
then
is
it's-
fast, this
and then
is
it's
phenomenal
what,
to me.
and then it's what do we do next? If
Absolutely, it's
not
like, look, let me explain like what this like
And
provide
it's
you.
not just the GYNs, you know, we think of the GYNs, you know, everybody thinks of the GYNs first for pap smears and things like this. Because
Family.
yes, they see a lot of it every day,
Right.
but if you look at family practice primary care doctors, they see more
Right.
patients overall in the aggregate. They may see, you know, family practice doctor may see fewer per day, but all the family practice doctors see more in the aggregate.
Right.
So you can pick up both,
Great,
the
yeah.
specialist and the non-specialist, so just as.
And it's again, you can use it as a door
Vehicle,
to get in, you know,
yeah.
rather than trying to sell them on urine testing or even toxicology. It's that way, and it's kind of figuring out like, you know, what they're listening to. You know, if you're presenting toxicology, pharmacogenetics, or you know some specific, you know, women's testing, they might listening. You know.
That just is open.
Absolutely.
And then, and because I don't know where this is in the market, so how that floats into insurance coverage for this.
Excellent question. If we look back at that molecular model that's up there, where we have the pharmacogenetics, the inherited disease, the infectious disease, and the oncology, the three on the right, inherited disease, infectious disease, and oncology, are well covered by insurance.
Okay.
The only ones where insurance companies are pushing back is on pharmacogenetics. Why are they pushing back on pharmacogenetics? Like Wolf had mentioned earlier, it's one gene, one time in your life, right? For the patient, because you don't need to do it again. So if I'm Blue Cross Blue Shield and you're AvMed, what do I want? I want you to pay for that. And what do you want? You want me to pay for that. So that's why the insurance companies are doing pushback. None of them want to pay for it. They love the idea. They don't, and I'll take that back, none of them want to pay for it. They do pay for it. We have processes to get paid. But they don't want to come out with a policy of doing it, because then everybody will get it done and they're going to be spending money. So they want to push back. We've had the head of many insurance companies in here, and they've specifically said, I love this. I love it, great. I want my competitor to pay for it. Because that's the way they think.
Yeah, I heard.
How much approximately are they paying for the pharmacogenetic testing?
Pharmacogenetics testing ranges anywhere from $500 to $5,000. is what we're seeing from insurance. That's a huge spread, but that's the spread. The average, we're probably getting in the neighborhood of $2,000 for the comprehensive panel.
But that can be billed to the insurance company.
Absolutely.
So do we want to market individuals for more of the pharmacy genetics?
You can do that too. Yep. So,
I guess-
questions on these?
Okay.
A lot of stuff to think, right? So the nice thing is virtually everything else we do is a catalog sale. You can get an interesting conversation going with a doctor on this, whether they're interested or not, whether it's a special or not, you can get an interesting conversation. And then you can say, oh, and by the way, here's everything else we do. Do you do any of these too, doctor? And they'll say, oh yeah, I do this and that. So you can expand your bag really easily with the catalog sale side.